Phil! Are you eating Chinese food again? You know, you're the laziest scum that's ever walked through this building. I should have fired you a long time ago. Ever since you walked in that day after you said you tore your ACL, you came in saying, I tore my ACL, I tore my ACL. And you've been in that stupid cast since. You haven't done a thing. You know the day after I tore my ACL, I played football. You want to know how many touchdowns I scored? 2. Beat that! 2 touchdowns! You can't even walk, you lazy scum. Alright, let's see. I need to give you an assignment. Let's see if you can actually handle it, you idiot. Alright, basically, we're going to be rolling out 3 more new lines of refrigerators. If you've been paying attention at all, you would know that. And so I need to figure out how much it's going to cost. So I did most of the work. You just have to finish it up. I printed out a table for you with how many parts per model are in each of the refrigerators, and then how much each of those parts costs us. So you need to figure out how much it will cost us to produce each of those refrigerators. Do you think you can do that, you photocopying moron? If not, it's your ass out the building. You know that, right? Good boy, Phil.
What is this? I can't do this. This is too hard. I hate math. I love Chinese food. Did someone say math? Yeah? Hi there. I'm the fairy math mother, and I'm here to solve all your troubles. All you need to know is matrices. Hit it!
Matrices. Definitions, addition, and multiplication. Let's see what your boss gave you. A parts per model chart listing the number of each of the 3 parts needed to build each of the 3 models, and a cost per part chart listing how much each of these 3 parts cost. While they may not look it, these are both matrices. A matrix is simply a rectangular arrangement of real numbers. A matrix is useful because it conveniently displays information. Usually, however, we represent matrices like this. Here are the 2 matrices your boss gave you, represented in the standard matrix format. Let's look more closely at the format of a matrix. This is matrix A. It is a 3 by 5 matrix. It is 3 by 5 because it has 3 rows and 5 columns. Note that because the dimension of the matrix is 3 by 5, it has 15 elements, meaning that there are 15 numbers in the matrix. Let's look at another matrix, matrix B. It has 2 rows and 4 columns. Therefore, matrix B is a 2 by 4 matrix. Note that uppercase letters are used to represent matrices. For example, B. Corresponding lowercase letters indicate the various elements in the matrix. A subscript is used to indicate the exact element. For example, B subscript 2, 3. The first number indicates the row, the second indicates the column. Based on this information, we can locate the specified element. First, we highlight the second row. Then, we highlight the third column. The intersection is the specified element, B, 2, 3, which in this case equals 5. Matrix addition. 2 matrices can be added together, but only if they have the same dimensions. For example, here are 2 matrices. Both are 3 by 4. Therefore, they have the same dimensions and can be added together. Addition is performed by adding the corresponding elements. To find the element in the first row of the first column, we must add the corresponding element in the first matrix, which is 3, and the second matrix, which is 0. We add these 2 numbers to get 3. Therefore, the element in the first column of the first row is 3. We do the same process to find the other elements. For example, to find the element in the second row of the first column, we find the corresponding element in the first matrix and the second matrix and add them together, giving us the element that we are looking for, which happens to be equal to 5. We then repeat this process to find all the elements of the matrix. This means that if matrix A plus matrix B equals matrix C, then element A subscript I, J, meaning the element in row I, column J of matrix A, plus B subscript ij equals C subscript ij. Scalar multiplication. It is possible to multiply a matrix by a number. For example, matrix A can be multiplied by 2. Since multiplication is repeated addition, you just add the matrix to itself. This is the equivalent of simply multiplying each of the elements by 2, yielding the answer. Note that it is always possible to add a matrix to itself, and hence perform scalar multiplication, because it has the same dimensions as itself. Matrix multiplication. Let's take a look at the information given to you by your boss. Here is the cost per part matrix and the parts per model matrix. Your boss told you to find the cost of each model, which would be the cost per model matrix. This can be found through matrix multiplication. To understand how matrix multiplication works, let's find the price for model 1. Cost for model 1. Here we have the cost per part matrix and the parts per model 1 matrix. We want to find how much it will cost to make model 1 by adding the cost of each of the parts required. First, we find the cost of all the part A's we need. To do this, we take the price of part A, $3, and multiply it by the number of part A's we need, 2, for a total of $6. We then do the same for part B. We multiply the price by the number we need to yield the total cost of that part, $5. We repeat the process for part C. We multiply the price by the number we need to get the total cost for that part, $16. Then, to find the total price for the whole refrigerator, we simply add the cost of all the parts, yielding a total cost of $27. We can now apply the same idea to find the entire cost per model matrix. In effect, we are multiplying the cost per part matrix by the parts per model matrix to get the cost per model matrix. We can fill in the first box, the cost per model 1, with the information we just found, $27. We can now do the same thing we did to find the cost of model 1 to find the cost of the other models. To find the cost of model 2, we multiply the cost of each part by the number of parts we need and add them all together to get $37. We then do the same thing for model 3 to get $19. Here is what it would look like if we were to represent what we just did in the usual matrix format. Let's look more closely at matrix multiplication. Here is the example we just did. Note that what we did is we took the elements of the first row of the first matrix and multiplied them by the first column of the second matrix to get the element in the first row of the first column of the final matrix. If we look at the dimensions of the matrices, we see that the number of columns in the first matrix is equal to the number of rows in the second matrix. This must be true to perform matrix multiplication. Here is another example of matrix multiplication. Here, we are multiplying a 2 by 3 and a 3 by 4 to get a 2 by 4. To perform the multiplications, we must multiply the first row of the first matrix by the first column of the second matrix to get the element in the first row and the first column of the final matrix. Note that what we really did was multiply the 1 of the first matrix by the 7 of the second matrix and add that to the product of the 2 and the 9 and the product of the 5 and the negative 5, yielding a total of 0. To find the other elements, we continue with the same idea. For example, the second row of the first matrix multiplied by the fourth column of the second matrix gives us the elements in the second row and fourth column of the final matrix, -4. Note that this multiplication could be performed because the number of columns of the first matrix equals the number of rows of the second matrix. Also notice that the number of rows of the final matrix is equal to the number of rows of the first matrix, and the number of columns of the final matrix are equal to the number of columns of the second matrix. But if the order of the matrices is reversed, when we try to multiply the first row of the first matrix by the first column of the second, there is a problem. While the 7 can be multiplied by the 1, and the 6 can be multiplied by the 0, there are no numbers to multiply the 2 and 3 by. Therefore, this multiplication cannot be done, and the answer is undefined. The reason for this is made clear by looking at the dimensions of the matrices. The number of columns of the first does not equal the number of rows of the second. Therefore, they cannot be multiplied.
And that's all there is to it. Thanks, Fairy Math Mother. I love math and Chinese food.